So it's a pleasure for me today to introduce today's speaker, Dr. Evan Fraser. Evan is the second of this year's 1-2 punch from the University of Guelph. The first you may remember having been Emma Allen-Virco, who spoke to us in the fall about the microbiome present in our digestive systems. Myself and a few others from senior college listened to Drs. Fraser and Allen-Virco speak at the meeting of CURAC, held almost 2 years ago now at the University of Guelph. And we all agreed very heartily that they would both be excellent speakers to senior college. And so we now have the second of those two. Evan grew up in a farming family on the Niagara Peninsula. So you might say that things agricultural and related to food production are in his blood. However, he chose not to remain in farming and completed undergraduate and graduate degrees in forestry, anthropology, and agriculture at the Universities of Toronto and British Columbia. He then took an academic position at the University of Leeds, where he was about approximately 10 years, maybe a little bit less, I believe, and then moved to the Department of Geography at the University of Guelph. He's been in Guelph for about 10 years, and he currently holds the Tier 1 Canada Research Chair in Global Food Security. He also helps lead the research program, Food from Thought, which is funded in part by a $76 million grant from the Canada First Research Excellence Fund. And he serves as a director of the Arrell Food Institute, excuse me, which was established in 1999 with a $20 million donation from the Arrell Family Foundation, and this was matched by the University of Guelph. So lots of research funds available there. Evan's many contributions and output are impressive. He's published over 100 academic papers and book chapters, and according to what I read on the web, these have been cited around 95,000 times, but I expect by now they're probably over 10,000 times. The titles, I was looking through the titles of some of his papers, and I just thought they were sort of interesting because they provide some insight into the reach and range of his research. So I'm just going to read a few of the titles. Smart Poultry Management, Smart Sensors, Big Data, and the Internet of Things. That's one. Another one is, quotes, we are a business, not a social service agency, end quotes, barriers to widening access for low-income shoppers in alternate food market spaces. Another one, high food prices in urban Cameroon, coping strategies and suggested policy actions. And the final one, which really did catch my eye, should I stay or should I go? Fisher's ability and willingness to adapt to environmental change in Cambodia's Tonle Sap Lake. This one caught my eye because a couple of years ago we were in Cambodia and at Tonle Sap Lake, and it really is one of the wonders of the world, I think, that no one knows anything about. It's just a fantastic place, look it up. So in addition to the journal articles, Evan is the author of 2 nonfiction books about food and food security. He's written a graphic novel. He's written numerous pieces for the popular news media and magazines such as the Globe and Mail, the Guardian, the Walrus, CNN, and other outlets. And he's the author of 3-hour-long segments on food security for Ideas on CBC Radio. He's mentored in a relatively short time over 50 graduate students. A working group dealing with the food industry that Evan co-convened advocated for the establishment of a Canadian National Food Policy Advisory Council, and this was actually, in fact, created by the federal government in 2019. Not many of us can say we had that direct effect on government policy, although some of us can, I know. Finally, Evan was the founder in 2012 of Feeding 9 Billion, a reference to the future global population. The focus of this initiative is on students and providing educational resources for teachers in the classroom. It has produced, amongst other things, an animated video series about global food security that has been viewed over 500,000 times, and I've watched some of it. It is quite neat. It's produced an award-winning card game, which I'm going to send to my grandchildren. It's a graphic novel and an audio drama. So if and when you have some time, and most of us have some time nowadays, it's worth going to the website for Feeding 9 Billion. Just type in Feeding 9 Billion and spend a little time exploring the site. as well as that of the Arrell Institute, the website for the Arrell Institute, which also has a lot of really interesting stuff on it. So I could go on and on. There's much to say, but I think I've said enough. So Evan, I will pass it over to you at this moment. So you will have to unmute, push share screen, click share screen, and it's all yours.
Oh, thank you, Jim. That was very kind of you. Nice to be given the opportunity to speak to you all. First of all, just give me a thumbs up that I'm coming through loud and clear and you can see a bright red screen with a title slide on it. I'm getting some thumbs up. Okay, cool, good. So, I mean, boy, I wish I was in Toronto. As Jim mentioned, I have 2 degrees from the University of Toronto St. George campus. I met my wife there, and boy, I do enjoy the opportunity to hit the old stomping grounds, but that's not going to happen today, unfortunately. And Guelph isn't that far away, but it's pretty far away in the current context. As you can see from the title of my talk, I want to speak to you about one of the world's biggest problems, which is how are we actually going to feed the future? But before I do that, let me explain about what this talk is and isn't about as a way of framing things up. To be very clear, I really want to be clear on this point. What I am going to talk about is the potential for technology to allow us the ability to produce more nutritious food, thereby meeting the aggregate needs of the growing human population and reduce the environmental footprint of our food production system. That's what I'm focusing on. What I'm not going to talk about is food insecurity. That is a social issue, an economic problem linked with low income, inequality, colonialism, racism, marginalization. And that set of social issues prevents people from being able to access food. Not that that topic's not important, it's just that would be a very different talk than the one I'm going to give today. So to put this as clearly as I can, I believe that we can make agriculture as sustainable as possible and produce enough food, enough healthy food for everyone. And yet we would still have people who, due to poverty or marginalization, do not have access to the right kinds of food. Now, I'm happy to talk about these questions in the Q&A, but I just wanted to be clear that I'm focusing more on food production as opposed to access to food. And so with that said, let me give you a quick outline or a game plan for the next few minutes. And I've divided my remarks into 3 sort of mini talks in a sense. Part 1 is going to be about the challenge of feeding the world and the growing population. Part 2 is about 3 different types of technology that I think may be very interesting in meeting that challenge. And then part 3, I'll drill into what I think are the sort of policy or instrumental things we need to do in order to meet this challenge. But Jim, I've done a lot of these sort of talks over the last 9 months, and I'm finding that it's sometimes better to break things up a little bit. So what I would propose, if that's okay with you folks, is that at the end of each of these 3 chapters, I'll pause and I'll take a chance to look at the chat box. And if you've got questions about that chapter, maybe fire them into the text box. I'll pause and we can have a bit of a Q&A, mini Q&A about that chapter. And then I'll go on to the next chapter. And then at the end, we can open the floor right up. So I'm just going to sort of fire ahead with that as a bit of a game plan, but then maybe I'll try pausing if people want to jump in and ask me things. All right, so with that said, let's start with part 1, the challenge. And I would say that an appropriate place to start a talk about the challenge of producing enough healthy, sustainable food for Feed the Future is actually with population growth. And as most folks know, probably, the world's population is currently at around 8 billion, is set to grow to somewhere between 9 and 9.5 over the next couple of decades. And then it was really interesting. This is actually one of these parts of my talk that is changing a lot radically. A year ago, if I'd given this, even actually in April, if I'd given this talk, I would have said that most population models project that the population will then continue to grow to late this century at somewhere around 9.5 to 11 billion. But just a few months ago, The Lancet actually published a whole lot of new demographic statistics that suggested actually that the population at the back end of the century isn't going to be rising as quickly as even we thought a few months ago. So that may be a good thing for our planet, but at least for the next 30 years, we are going to have to contend with rising population numbers. And from a food perspective, of course, that means we need food, a lot more food. And according to The Economist magazine that ran a piece on this a few years ago, in the next 40 years, humans are likely to need to produce more food than they did in the last 10,000 put together. So I think it's worth sort of pausing for a second and just reflecting on the gargantuan nature of the challenge we actually do feed in terms of sustenance. At the same time, of course, we need to contend with climate change that in all likelihood will make food harder and more expensive to produce, may make some parts of the world completely unable to produce food, but actually in somewhere like Canada may actually give us opportunities to farm more intensively or even expand agriculture northwards. But that's a separate talk as well. But if you're interested in that issue, I'm happy to talk to that in the Q&A. But hey, when I talk about food security and the challenge of feeding the future in this way, it sounds like it's all about producing more. And oh my goodness, if only it were that simple. We also have to contend with the fact that the food system that we've got today is actually extremely inequitable. And I can think of no better way to sort of share with you the inequities of the global food system than to show you two photographs from my favorite photo essay of all time, which is called The Hungry Planet by Faith DeLuzio and Peter Menzel. And this was published, I think, about 15 years ago now. And the two journalists had the genius idea, in my opinion anyways, of traveling around the world and taking formal family portraits with families from different cultures. But the great thing was that they posed each family with 1 week's worth of groceries. And in this way, The Hungry Planet introduces us to the Revis family from North Carolina, who, at the time the book was published, spent about $85 per person per week on food. And here, again, it's worth pausing and appreciating what you're seeing. The color of the North American diet, the packaging that goes into our diet, the extraordinary lack of fresh fruits and vegetables in the North American diet. And of course, the obvious comparison with the Ntomo family from Mali, who spent, when this photo essay was constructed, $1.76 per person per week on food, and eat a largely vegetarian diet free from packaging. And of course, you can't help but look at these photographs and conclude that we live in a deeply, a structurally inequitable world. And indeed, you don't have to rely on journalists and family portraits to come to that conclusion. The data really does back that up. Here we see the cover from the most recent, just published last fall, annual UN State of Food Insecurity or Food Security and Nutrition in the World report. This comes out every year, and it makes for some very, very sobering readings. It shows that for the last 5 years, both hunger and obesity have been rising globally. Now, this is a really interesting switch because obesity has been rising for 30 or 40 years globally, but hunger up until 5 years ago had been coming down both in absolute and proportional terms. But around 2015, due to a combination of conflict and climate change, we start seeing rises in hunger for the first time in a generation, both in proportional and absolute terms. And indeed, COVID-19 has amplified this trend enormously. So with that, we also have to ask a bunch of other questions about our food. We have to ask the question, are we producing the right kinds of food for everyone to eat a healthy diet? And here too, the data is also sobering. What I'm going to share with you here is probably something you folks that saw me talk a couple years ago saw a slide that I keep using because it's a powerful one. On the left-hand side of this screen will appear what we should be eating according to the well-known nutritional guidelines out of Harvard University, the Harvard Healthy Eating Plate Model, which is very, very similar actually to the new Canadian Food Guide that came out about 2 years ago. And on the right-hand side, I'm going to contrast the nutritional recommendations with actual UN data that explores what we are actually producing. And we begin with the fruits and vegetables that we all know we should be eating more of. And according to the nutritionists, about half of our diet, half of our plates should be fruits and vegetables. Yet when we look at the data, we only produce a fraction of what we need if we were to actually eat that diet. Indeed, the paper that I worked on a couple years ago that is cited at the bottom it suggests, our calculations suggest we would have to triple or even quadruple global fruit and vegetable production if we all of humanity, wanted to enjoy a healthy diet. By contrast, we should only have about 20% of our diets be cereals and starches, and the nutritionist would then further recommend that these be whole grains, not refined grains, whereas the majority of the world's food is cereals and starches. And this is really important to note this. This is not cereals and starches for livestock. This is just cereals and starches produced primarily for human consumption. The United Nations data is very clear on that point. Oils and fats should make up a small proportion of our diet, yet represent a big part of the global food system. And if you think of palm oil and soy oil and vegetable oil, corn oil, meats and alternatives and dairy products are actually a little difficult to interrogate or draw conclusions from, given that there's a real lack of consensus amongst the nutritional community about how much or even if we should be eating these products. So I'm going to move through this and get to the real kicker, which is the sugars. Things that we should be limiting, yet represent a huge proportion of the global food system. And so, another sobering moment, when you see the data presented in this way, for me anyways, it's very difficult to conclude anything except that there is a fundamental mismatch between what we produce and what we should be eating. And this mismatch probably has something to do with the skyrocketing obesity and diabetes epidemic. Moving on, we have to also contend with the issue of food waste. Most reports suggest that something between a third and a half of the world's food is never eaten by a human. It's spoiled, it's thrown out, it's devoured by rodents, or just ends up in landfill. And to put this in a context, here's some data published a few years ago by the city of Vancouver. In Metro Vancouver, 80,000 potatoes, 30,000 eggs, and 70,000 cups of milk are disposed of each day. And then, of course, there's agriculture's environmental footprint. In addition to being responsible for approximately a third of the world's greenhouse gases, agriculture is also the world's largest driver of habitat and biodiversity loss. It's the world's largest user of fresh water and is the biggest source of water pollution. All of which, by way of part one of my talk, is to say that developing strategies to nutritiously, equitably, sustainably feed the world's growing population has to be seen as one of the biggest challenges we face over the next generation. So I'd now like to move on to part two of my talk question, and then I'll press on.
That's it.
That's it. Okay, right. Okay, perfect. Let me just jump my slides forward then. There we go. Okay, so we're now going to use that horrible 2020s word and pivot and discuss how I think technology, at least in part, can provide some of the solution to these problems that we've just been talking about. But remember, my opening remarks to you all a few minutes ago, this is a talk about how technology can allow us to produce nutritious food. And we're not talking about the sort of the poverty demand side issues, which I'm only too happy to discuss, but that's a different talk. And I sometimes get myself in trouble because I don't make these caveats very explicit at the outset. But in order to set this part of my talk up, let me share with you an anecdote that I sometimes use to illustrate, the scale of the technological changes currently underway in farming systems. And as Jim said when he gave you my bio, I in part grew up on my grandpa's farm, which is outside of Niagara Falls, so not far from where any of us are sitting. And this is me sitting on grandpa's lap, my brother and my cousins on the back. And the reason I'm throwing this up is when I was a teenager, I would spend a lot of time standing on the back of this tractor. And grandpa would drive slowly through the fields, strawberries, sweet corn, melons, etc. And one of my jobs was to throw handfuls of fertilizer pellets off the tractor and onto the waiting crop. Now, with the benefit of hindsight and a PhD in agriculture, I'm going to now estimate that 50% of the fertilizer that I threw in that way simply did not end up at the right place at the right time for plants to utilize. And so it either worked its way into the atmosphere as a greenhouse gas, or it worked its way into the water table as water pollution and, contributed to the algae blooms in Lake Erie, to be completely honest. But that was way back in the dark ages of the 1980s and the 1990s. And so that was then, and this is now, the fully autonomous smart tractor that is capable of knowing, and I use that word in quotations, the tractor is capable of knowing where in the field to plant things, how much fertilizer to apply, when to apply the fertilizer, with absolute stunning efficiency. Now, the advent of these sort of high-tech robotic tools is sometimes called the digital agricultural revolution. Sometimes it's called Ag 4.0, lots of different monikers for it. But the application or applying these sort of tools to farming, I think, began about 10 years ago. And something similar is happening in other sectors, such as dairy, where increasingly farmers are using robotic milkers, such as the one pictured here, that are able to more or less autonomously milk cows whenever the cow chooses. And while the cow's being milked, the robots capture a range of biometric data that helps farmers monitor herd health, enhances nutrition, maintains productivity, and also reduces potentially harmful inputs such as antibiotics. So let me explain that in a bit more detail. The robotic milkers in particular are able, on a teat-by-teat basis, so the udder's got 4 teats, on a teat-by-teat basis, on a second-by-second basis, twice a day when the cow's being milked, measure very minute changes in milk quantity, the temperature of the milk, the conductivity of the milk, or how easily it passes an electric current through it. And using those data, the robot is able to identify mastitis probably before the cow even knows she's sick, let alone the farmer identifies a sick cow and calls a vet. And treat it early, helping a cow recover from mastitis, when it's identified so much earlier in the development of the disease, requires very little in the way of antibiotics and even very little in the way of interruptions in terms of milking schedules for the farm. So it's a real benefit, I would say, this technology. And similar changes are happening up and down the food chain. And it includes, smart packaging that both biodegrades, but also changes color when food's going bad. And I've got a close colleague at the University of Guelph who's working on exactly that. That enhances food safety, reduces food waste, reduces plastic pollution in the environment, all sorts of good things. Other sort of kinds of technologies would be what's called a blockchain-enabled e-commerce platform. I don't want to get into the details of all that bafflegab, but imagine a set of websites or databases that would allow you, a consumer, to really have a strong line of sight back through the steps, when the food was produced, where it was produced, how it was handled, all the way back through to the farmer. And the farmer peers through the supply chain at the consumer to knows where demand is changing and whether their products are being well received. As a result of these kind of tools, many experts believe, and I'm one of them, that the next big digital frontier will be the application of artificial intelligence, robotics, et cetera, to farming systems. And this has resulted in huge flows, growing flows of investment into the agriculture food technology space. So this is a screen capture from the industry watcher called AgFunder, who points out that in 2019, $20 billion was invested in ag technology, which is a 6-fold increase since 2012. And frankly, the literature gets quite breathless with excitement that not only are there huge business opportunities waiting, but we can also produce more food on less land, reduce waste, and thereby feed the world's growing population and shrink our environmental footprint all at the same time. Now, let's pause. If all that sounds too good to be true, then I think you have every right to be skeptical. And I really do believe that there are incredible potentials here. And I also believe that we have to be very, very critical and have our critical thinking hats screwed on really tight when we think about how these technologies are going to be used. So I'd like to turn and explore a few of the key technologies, 3 in particular, that I think are both extremely exciting, but also where I think there's a lot of complexity and nuance required if we want to do anything like realize this vision of a more food with less environmental impact, lots of money kind of future. So let's start technology number 1. Let's start in the broad area of precision agriculture as applied to grain fields, oil seeds, wheat, corn, canola, that sort of stuff. This is quintessentially big commodity agriculture and is epitomized by that smart tractor that I showed you a few minutes ago. And in my opinion, the promise of this technology is that things like low-cost soil sensors that measure everything from temperature and moisture in the soil through to GIS systems and satellite imagery will allow farmers the databases to precisely apply exactly the right amount of fertilizer and plant exactly the right kind of seed on a meter by meter basis in a farm. And smart tractors are able to do this because of onboard analytics that essentially divide fields up into what are called management units, pictured in this slide on the left-hand side in the green and the yellow and the red. And so as a tractor autonomously drives through a field using the data, it recognizes it when it moves from a high productivity green management zone into, say, a low productivity red management zone. And that triggers the algorithms, the decision-making tools in the tractor to decide whether maybe to plant a drought-tolerant variety of corn or put a little bit of extra fertilizer on or do whatever the management practices are required. And one of my favorite companies that's working in this space is a Canadian company named Dot Tractors, pictured here in this slide. Now, Dot was recently itself bought by the US technology giant Raven, but they are pioneering 100% hands-free harvesters, seeders, fertilizers. And seeing these creatures, these machines in the field is a little bit like watching the little red hen meets the Terminator. They're doing everything and they're doing it well. But while I'm impressed with the sophistication of these tools, there's some important cautionary notes and complexities that really need to be explored. And I want to share with you two pieces of research that I think reveal that all is not necessarily as seamless as the marketing brochures might allow. And the first piece of research is something I was involved in a couple of years ago, and it was led by a colleague of mine named Madhur Anand from the University of Guelph. And the postdoc working in Madhur's lab was able to get some of the data from these smart tractors and use the data to make on a meter by meter basis a calculation of the profitability of a series of fields. So what you're looking at in this slide is a profitability map, which was based on the yield on a meter by meter basis, the market value of the crop, and the cost of the inputs. And what you're seeing here is the red areas are areas where this farmer lost money in this year. And the yellow areas they broke even on, and the green areas they profited on. Now, I have to acknowledge this was a poor year for soybeans, and most fields don't look this bad most years, thank goodness, or we'd have a lot more out of work farmers. But we had a really interesting experience when we presented this information back to farmers. First of all, the scientists that did the work on this paper, myself included, we were sort of hoping that farmers would look at the red areas and go, oh, maybe we should take this area out of cultivation, perhaps turn this area that's losing me money over to pollinator habitat or something that would be good for the environment. That was kind of what we were hoping the conversation would go. But what we heard was actually different. And it exposes, I think, the naivety that sometimes us scientists bring to our subjects. Many farmers, first of all, simply said they already knew where in their fields wasn't productive and where was productive. And so the additional insights from this fancy tractor were not all that exciting to them. But in one instance, a farmer pointed at a red area and said, well, that's got a lot of shade trees in it. I mean, I like those shade trees, but I've got a mortgage to pay and I've got kids in college. Maybe I should just cut those shade trees down, farm more profitably across my field, and I'll be better off. So that wasn't really the kind of environmental conclusion that the scientists were really hoping for. So overall, presenting the material back to farmers really, for me, raised a question, which was how much benefit does this technology have to offer before it pays off? The second piece of research that I'll share with you about this is similar in terms of where its implications. And it comes out of the economics of fertilizer application, which might sound really boring, but I think we can do one graph of the economics of fertilizer applications. And what you're looking at here is what an agricultural economist would call a nutrient response curve that shows the relationship between the amount of fertilizer applied, that's the x-axis, it's the amount of nitrogen applied on a field, and the y-axis is a measure of the productivity of the field. And what research on nutrient response curves generally shows is a relatively flat response. Yes, there is an optimal amount of nitrogen that can be applied, but there really aren't super big gains if a farmer is super precise. In fact that the first part of the curve is steeper than the second part and it flattens off suggests that if a farmer underapplies fertilizer, they may pay a real penalty in terms of yield. However, so long as fertilizer costs are low, then a farmer doesn't pay much, if any, penalty if they overapply fertilizer. Of course, the environment pays a price for overapplying fertilizer, kind of like me chucking handfuls of fertilizer off my grandfather's tractor. But for the farmer, there actually seems to be a larger penalty associated with not putting enough fertilizer down as opposed to putting too much down. And all told, this research, both pieces of research I just shared with you, makes me actually question whether or not this broad area of precision agriculture will really have that big an impact on the environmental performance of farms in North America, especially when we're talking about large fields like wheat fields in the Canadian prairies or corn in the US Midwest. And with all of that said, this isn't to say I think these technologies are a bust. Far from it. I actually think that it's possible that these technologies may, in the very, very near future, take us all in a very different direction in terms of farming entirely. So here we see what's called a tractor swarm. It's a small network of autonomous linked vehicles that can be controlled by an iPad or a similar device. We're actually starting to see tractor swarms like this be used in places in India, Latin America, Africa, where small farms still dominate. And interestingly, tractor swarms are typically managed by Uber-like companies, such that a small-scale farmer or a group of small-scale farmers simply rents the service of a swarm for a short period of time and a specific task. And this reduces the need for farmers to be investing in extremely capital-intensive equipment. So where my thinking is at today on this broad area is that perhaps the big gains in terms of precision agriculture are not going to be found in Canada or the US, but actually going to be found in parts of the world where small farmers are still common and capital is limited. All right, let me go on to technology number 2. I wanted to share with you 3 technologies which I get excited about. And the second technology is the broad area of indoor horticulture, which includes greenhouses, but also includes vertical farms producing vegetables right in downtown Toronto and big skyscrapers. And my prediction is that over the next 5 years, so not a long time, is that there is going to be a rapid deployment of technologies that will bring fruit and vegetable production both indoors and much closer to home, even in places like Canada, where the growing season typically means it's difficult to do this stuff year round. For instance, we all know we've got a well-established tomato, cucumber, and pepper operation. Greenhouse operation in Ontario gives us high quality year-round products, pretty affordable, and it uses a wide range of sophisticated tools, including automation, LED lights, assisting when sunlight isn't sufficient, hydroponics, etc. In addition, the left-hand slide of this picture, of this slide rather, is the press announcement of the farm called Moochie Farm. It's not far from Guelph. It's just over by Lake Huron. A couple years ago, they opened North America's largest indoor strawberry greenhouse that actually can produce strawberries 11 months a year locally. And they do this using a combination of LED lights, automation, and specially bred strawberry plants. As a result, proponents of this sector mean that we are rapidly moving into a situation where we will be able to produce, quote, any crop, anywhere, anytime. And I have a close colleague at the University of Guelph who was a consultant for that movie, The Martian, a few years ago. And he says if we could start growing, salads on Mars, we can certainly grow them in a snowbank in Alaska. And so here's an image of one of these vertical farms with trays and trays and trays of lettuce grown in highly controlled environments. Good colleague of mine from the West Coast says you can actually get somewhere between 100 and 1,000 times the yield per hectare in a vertical farm that you can in a field situation, and you can do it year round. And this vision is that the sort of technology could be deployed in our cities in the very near future to meet many of our needs hyper-locally. But while I think this technology has huge potential, I also think we're not quite there yet. So there's always a bit of a but in this conversation that I'm giving to you today. In particular, I think there's some really important pieces of research that we need to undertake if we want to come even close to realizing this kind of ambition. First, we need varieties of crops that are bred specifically for indoor year-round production. At the moment, most vertical farms focus on microgreens and green leafy vegetables. There's a little bit of stuff on strawberries, but it's just beginning. We really need to do some sophisticated plant breeding genetic work on strawberries, blueberries, cherries, avocados. I don't know, I'm just listing off my favorite foods here, but there's a lot of plant breeding and plant genetic work to be done. Second, we are becoming aware that a huge amount of the taste and nutritional components of fruits and vegetables are actually determined by the community of microorganisms that live in and around the plant. You'd mentioned that you'd heard from Emma Allen Verco back before Christmas. She talked to you about the microbiome of the human gut. There is a microbiome that is equally important that sits at that interface between soil and root, and that drives the flavor of a huge number of crops. And we don't really understand any of that. And you can, we think, replicate some of that using bacterial inoculants that plants would grow in. But oh my goodness, this is a broad and exciting area of science that we need to be working on hard. Third, hardly surprising, we need to work more on mechanical harvesting and automation to reduce labor costs associated with indoor production, because that's a big limiting factor. And fourth, we need to be doing research on how indoor varieties of fruits and vegetables perform differently under different lighting conditions, because we're now talking about using LED instead of sunlight. Now, I've given you a lot of scientific jargon in the last slide, and I don't want to dwell much on these different research priorities. If people are interested, I'm delighted to, and I'll stop after my third type of technology and take questions, which I'm happy to talk to. What I would like to do is illustrate the kinds of research that I'm talking about by just sharing one example piece of research about LED lighting that I find particularly fascinating. And here's the results of some work on how lettuce responds differently to different LED lighting conditions that was done by my colleague Mike Dixon at the University of Guelph, who's the guy that was the consultant on the Martian movie. And what this slide shows is that lettuce grown under red light in the middle actually grows much more bountiful and has about 2 times the biomass, whereas lettuce grown under blue light on the right becomes purple with antioxidants, and then the white light on the left is the control. And what Mike has discovered is that you can really boost the value, commercial value, nutritional value of lettuce by starting with red light, thus promoting plant growth, and then switching to blue light, giving the plant antioxidants. And Mike says each plant has a different light recipe, and we need to be doing work on that. And for me, this illustrates in a nice tight way the potential of research on indoor controlled environment agriculture, where farmers can do everything from control wavelengths to temperature, humidity, other atmospheric conditions, and really change how we produce fruits and vegetables. And as a result, unsurprisingly, this technology is really capturing a lot of interest. One of the industry leaders is based on the West Coast. It's called Plenty Foods. They have a really ambitious plan to set up indoor lettuce production facilities all across North America. They raised about $200 million a couple of years ago. And just a few months ago, I think it was October. Yeah, there we go. The date is on the slide, October 15th. They announced they were teaming up with one of the world's largest strawberry producers and had raised an additional $140 million to do the technologies for indoor strawberries. Okay, I now want to shift and start talking about technology number 3, that protein one that I dodged that question a few minutes ago. I'm now going to try to answer the question about protein, because I think the broad explosion of alternative protein has the potential to be incredibly disruptive to our food systems. It will bring good things, it will bring not so good things, but it is coming hard, and we better be ready for it. I spoke with the Dairy Farmers of Ontario's annual general meeting about 2 hours ago, and you could just sort of sense on the Zoom call the energy go out of the room when I started talking about the technologies that are about to start competing with dairy, and it is astounding. And here I'm talking about 2 kinds of technologies. I'm talking about plant-based technologies, as well as this advent of so-called cellular agriculture that involves synthesizing what are ostensible animal proteins in a laboratory. Now, these products hit the news in the summer of 2019 when companies such as Impossible Burger and Beyond Meat made their initial public offerings, went on the stock market for the first time, essentially becoming unicorns, to use the investor language, unicorns for investors, going up orders of magnitude in terms of share price. And since then, there's been a steady penetration into the market of both plant and cell-based alternatives. We now have massive industry-leading companies like Tyson Foods, one of the world's largest chicken producers, and Canada's own Maple Leaf, our largest food processor, investing heavily in the space. And for those of you who aren't aware, the Light Life burger, which is on the right-hand side of the slide, is a wholly owned subsidiary now of Maple Leaf Foods. So we have this extraordinary explosion of these alternative plant-based, cell-based products coming on the market. And there are endless controversies as well. Let's take the issue of consumer acceptance. A lot of consumers are concerned that these products, the products on this slide, are hyper-processed and extremely high in salt. They're also high in fiber. So you're trading salt against fiber if you eat one of these things. Other people are also skeptical of bioengineering and are concerned that many of the ingredients in these products are indeed the result of genetics experiments. For instance, the ingredient that gives this new generation of meatless burger its meaty flavor is a product called heme. It's a molecule that you find in any mammal's blood. It bonds the blood with iron. From a food science perspective, heme is what makes meat pink and juicy. It helps meat caramelize in a frying pan or on a grill. It makes meat meaty. But these products are using a bioengineered form of heme that it comes from yeast. So there is considerable debate as to whether these are good things in our diet. What we have in this slide is the CEO of Impossible Foods, one of these plant-based companies, saying that the cell-based world is never going to be a big thing, partly because of consumer acceptance. Cell ag is weirder than plant-based, but also because it's difficult to scale these, according to him. I actually think he's wrong, but there's controversy. And then, oh my goodness, there's the traditional livestock industry raising questions about whether these products should be called natural, or should you call a product dairy if it doesn't come from a cow, but has a molecule that is identical looking to a dairy protein. So I find this topic really fascinating. And even speaking as a relative insider, I don't know where the trajectory is going to take us. That said, a company jumped onto my radar just this summer that I think has the potential to really, really shake things up. And this is what I spoke to this morning to the dairy farmers. And it's a screen capture of the Californian-based company called Perfect Day that very explicitly positions itself as an agent of positive change. And if you look at the bottom right-hand part of this slide, which I've just highlighted, you can see that they even believe their process makes dairy perfect, a challenge that my friends in the dairy industry find deeply problematic, to put it mildly. At any rate, Perfect Day started about 5 years ago and has a typical tech startup story coming out of San Francisco with a couple of young chemical engineers out of Silicon Valley and a good idea. And what they did is they bioengineered a variety of yeast that digests sugars and starches and stuff, much like yeast does. And unlike brewer's yeast that produces alcohol when it ferments, or baker's yeast that produces carbon dioxide, this yeast produces dairy protein. And it does it in a bioreactor. And if I get the details of the Perfect Day story right, they initially positioned themselves as a company that would make consumer products such as vegan cheese, milk, yogurt, or ice cream. But about 2 years ago, Perfect Day pivoted and now just simply sells dairy proteins to ice cream makers. And this means that Perfect Day focuses simply on producing milk proteins as cheaply as possible, with as minimal an environmental footprint as possible, and have left the challenging business of producing and marketing products to consumers, actually to the experts. Today, ice cream made with Perfect Day dairy proteins are available across the US. They started selling them in the summer. I would love to try some, but I haven't because I can't travel to the US right now, but I have it on good authority from people who have tried it, that it actually makes really good ice cream. It is completely, from a culinary and a chemical perspective, indistinguishable from regular ice cream. It has the mouthfeel, it has the melting qualities, it has the creaminess of regular ice cream. Now, I can't test that claim because I've not been able to try it. But at the moment, Perfect Day Dairy is about twice the price of a premium quart of ice cream, and that's without having gone to scale for production and distribution. So with that as the introduction to the three types of technologies, I want to shift to talk about policy now. Bugs or herbicides? I don't know. It raises some interesting questions that I'm not going to try to answer. With regards to the using the technologies in order to promote ecosystem services, like that farmer didn't when he looked at the red areas on that map, I think the technologies give us the potential to, but until the system changes, until there are regulations in place to support the environment, I think it's unlikely we'll see those technologies used in that way. And actually, then that becomes a super good segue, because that's kind of the next part of the talk. So I think, with your permission, Jim, I'm just going to fire along and then talk about chapter 2, which will, in some ways, I think, build out some of that question. So since this is actually called the digital agricultural revolution, and because digital revolutions are all about harnessing data at their core, I'd like to start by talking about some data-related things I think need to be worked on if we want the digital revolution to work. And then I'll talk about some more general policies, like creating financial incentives for environmental stewardship, which is sort of the conversation we just had. So 3 data-related policies, and then 3 sort of more general policies, and then I'll just open the floor right up. So in terms of data-related policies, you'll see on this slide, I've put 3 sort of keywords down. Interoperability, which essentially is the ability of data to be collected in a way that's consistent so computers can use it. Ownership and governance, which also includes privacy and things like that, because we have to be worried about how we govern data. And cybersecurity, which is whether our data and our food systems, if we have data-driven food systems, become vulnerable to cybersecurity threats. So I don't want to spend much time talking about any of these topics in detail, but in brief, let's talk at a high level about data interoperability. One of the key challenges is that the digital agricultural revolution requires us to bring data from a whole lot of different sources into common architects. So if anyone on this call is a data scientist or has a background in computer science, you'll know all too well the technical challenges this entails. And here on this slide, we see some of the varied and complex kinds of data that need to be combined and integrated to make that smart tractor or that tractor swarm work. We need the satellites and the GPS systems and the steering systems all integrated together. Now, that is not easy stuff to do. And right now, a farmer that has a John Deere tractor versus and a Case International harvester, those 2 pieces of technology might not even be able to collect data in a way that could be pooled. So there is so many, frankly, boring data interoperability questions that need to be worked on if we ever want this sort of digital agricultural revolution thing to work. Second, as we all know, at least I hope we all know now, there is a huge concern in society in general over who owns data in general. A huge amount of ink has been spilled discussing how data should be governed. All of this stuff is now playing out in agriculture. So that whole story of Cambridge Analytica and Facebook and Amazon tracking you, all that stuff is playing out in agriculture right now. So for instance, farmers are concerned that they're being sold smart devices like smart tractors that then collect data, but they don't own the data. The data actually goes back to the company like the John Deere. And then John Deere turns around and says, if you want to use the full functionality of your smart tractor, you've got to buy a subscription in addition to paying $750,000 for the hardware. And frankly, and I get this, farmers are kind of like, no, I don't want to do that. That doesn't sound like this is in my best interests. So much like we're having a conversation about other aspects of society about who owns data, who benefits from data, and even issues like privacy. Like, I'm giving you my data, John Deere, and then anyhow. Ownership and governance around data is becoming a massive, massive issue. And then finally, it's only a matter of time, I think, before our digital food system becomes vulnerable to malicious cybercrime. So the screen capture here, what you're looking at, is the scene that doctors and nurses saw about 3 years ago in the UK when they sat down one May morning to pull up their patient health files. And some cyber criminals had launched a ransomware attack on the national health system of the United Kingdom and tied up patient data behind a Bitcoin ransomware attack. And I know the poultry industry is terrified about this. I talked to a poultry farmer. I have a friend, a computer scientist friend who knows a poultry farmer who 2 Christmases ago couldn't get into their ventilation system. And if a poultry farm's ventilation system is thrown offline, and these things are all driven by Internet of Things enabled Bluetooth devices, all driven through the farmer's smartphone. If a poultry's ventilation system is thrown offline, it's not very long before those birds die. So my friend, the computer scientist, went over to his friend, the poultry farmer, and started mucking around and solved the problem, luckily, but discovered that actually some cyber criminal had used an unsecured device that the farmer was using to access all of their personal information. There was identity theft, there was credit card theft. And then as the last step, one group of cyber criminals had sold access to this farm to another group of cyber criminals who launched the ransomware attack. So, oh my goodness, we are facing a major cybersecurity problem or threat with regards to moving our food into this digital domain. So we need to be moving agriculture quickly into the cybersecurity conversation. We need to be seeing agriculture much like financial technology. It's part of our critical national infrastructure. And if farmers, frankly, aren't trained in cybersecurity protocols, we are all vulnerable. And I'm worried about that. I'm really worried about that. So we've got a number of research projects and advocacy projects on cybersecurity and agriculture that have just launched in the last few months. All right. In terms of non-data related things that I think we need to work on if we're going to have a chance of deploying all these crazy technologies in a way that makes the world a better place is specifically, we need to put a price on pollution such as greenhouse gases or find a way of rewarding farmers for ecosystem services. I'll talk about that a bit more. We need to de-risk investment and funding in this space. And finally, we need to rethink how we train people because the world of the future is not like the world of the past. So let's talk about these 3 things in turn quickly. In terms of my recommendation around pollution pricing, I really, really believe that we need better policies that put a cost on environmental pollution, such as greenhouse gas emissions, or a cost on biodiversity. And this speaks specifically to that experience I had a couple of years ago with that red and green map and the farmer saying he'd cut the shade trees down. If we want to realize the benefits of this digital agricultural revolution to result in a reduction to our environmental footprint of farming, then we have to be rewarding farmers who actually do that work. We need to reward farmers or other agents who use this technology to actually create low carbon practices, create incentives to invest in clean technology. I realize that there's a tremendous discussion about this sort of thing in the broad parts of society, but I firmly believe that some sort of carbon market is necessary if we want to address this issue. I'd like to note that Canada's own Maple Leaf Food, which is our largest food processor, has voluntarily, about a year ago, become the world's first large food company that is carbon neutral. And I would say creating a carbon market in the food sector would reward companies like Maple Leaf and incentivize other companies from following that path. My second non-related recommendation relates to this issue of funding. And we need funding mechanisms to de-risk investment in this space. Reflecting back to this, although $20 billion invested in the entire, globally invested in ag tech sounds like a lot of money, and it's certainly a big increase from 10 years ago, it's a drop in the bucket of what's needed. If we really want to do the plant breeding, the green chemistry, the carbon markets, all that stuff that we're going to need to move agriculture into a better place, we need to recognize that it's going to take a lot more investment. And let's face it, this is one of the biggest global challenges facing humanity this century. So it's not going to be an easy one to solve. But people with big pockets and deep pockets, the investment community, they don't like agriculture very much right now because it takes a while to get a return on investment. Frankly, it's much harder to breed a drought-tolerant variety of wheat than it is to create a new generation of software or make some bets in the real estate market. So I think because we're working with biological systems, because things take longer in agriculture, because the investments are riskier, I think government needs to step in and help de-risk investment in this space or create incentives for investment in this space. And finally, this is something that is a personal project of passion for me, putting on my educator hat on. We need a new approach to training the next generation. Look, at present, both Canada, the US, EU, we're well served by a great network of universities and colleges, such as the University of Guelph, that teach the basic skills in ag and vet science. And this is important. I'm not saying anything else. This is really important. And we need to understand the traditional disciplines. but it's not enough. The industry leaders of tomorrow, quite frankly, they need to be data engineers, software scientists. We need to do a better job at bringing the STEM disciplines of science, technology, engineering, math into our agricultural classrooms. We also, and this is like a personal story, like I'm on a soapbox now, we need to be convincing the computer science and engineering schools to use agriculture for case studies, for co-op placements and things like that. In Canada, frankly, when I reach out and review these things, most engineering schools focus on aerospace and automotive and things like that. No one thinks about agriculture as a viable thing for a good quality engineering student to work on. And that's got to change. It just has to change. But that's not going to be enough either. But simply bringing agricultural disciplines and STEM together will not work. And this is because workplace study after workplace study illustrates that to be effective in the new world of work, students also need soft and foundational skills. They need teamwork skills, they need communication skills, critical thinking, conflict resolution, active listening, emotional intelligence. And we can train them. I mean, these are soft skills, and it's not like teaching a kid to differentiate an equation. Sorry, I've got a son who's studying for a calculus, second year calculus class right now. So I'm thinking about differentiations. But you know, you can teach these sound foundational skills. And so in my opinion, bringing these three core paradigms of education together, so traditional ag disciplines, STEM disciplines, and foundational skills, means that, boy, our universities and colleges need to rethink how we train people and what's necessary.